Correction of infant auricular deformities using 3D printing and computer modeling.
Hello, I understand that your infant has an ear deformity. Let's discuss your options. Let's start with the basics. Ear deformities occur in 1 in 10,000 births. The prior treatment was to surgically alter the ear. Remodeling is necessary for the prevention of psychological stress as the child ages. So why are the baby's ears so soft? Infants are born with high levels of maternal estrogen. Estrogen makes the cartilage malleable, making the ear a perfect candidate for remodeling. Estrogen levels deplete after 3 months of life, decreasing treatment efficacy as time goes on. So what do ear deformities look like? All deformities are unique and can range from mild to severe. Current devices on the market include infant ear and ear roll. There are several issues with current devices. The first one being is that treatment can cost up to $2,000 and is typically not covered by insurance. Second, these devices are generic and can cause skin irritation and are not optimal for unique deformities. Third, these devices fall off frequently and have to be constantly reattached.
Those don't sound promising. Are there any other treatment options?
These new devices cost efficient and has the potential to be covered by insurance. It can also be personalized to each infant's ear and can be easily reattached. It is also breathable and will limit skin irritation by the usage of biocompatible silicone.
That sounds wonderful. Let's give it a try.
This is our engineer, and she would explain how the device works.
Let's get started. Scan the infant's ear using the free iPhone app called Scandy Pro. Alter the scan and send it to Mesh Mixer. Mesh Mixer is the free software we can use to edit and manipulate the ear. Send the mold to the 3D printer or outsource if necessary.
How is the ear scanned?
Information about Scandy Pro. The iPhone app Scandy Pro captures 3D scans. This app is compatible with iPhone 10 and later models. Here's a quick video tutorial. Using Mesh Mixer, the scan is imported to Mesh Mixer. It is then edited to a corrected shape and placed into the mold template. Here's a quick video tutorial.
Once the ear is imported into Mesh Mixer, the simple user interface makes it easy to modify the ear. Here you see the Move, Draw, and Smooth tools on the left-hand side being used to fix the curvature of the helix and the depth of the scapula for this ear. When finished, the ear is subtracted from the base device and the final smoothing of rough edges can be done for additional comfort. The entire editing process only took 2 minutes for this patient. After making any final changes, the device is inspected for complications or mistakes. We then add the bottom component and check that everything lines up to see how it looks. Everything here looks great, and the device is ready to be printed.
Off to the printer, the finalized mold file is sent electronically to a 3D printer or outsourced to a 3D printing company. If printed in-house, the device can be ready in hours. If outsourced, the device typically arrives in 3 to 5 business days. When the package arrives, the device is ready to be fitted on the infant's ear. The printed prototype looks like this. There are 2 parts to the device. The back is a generic piece, and the top piece has a personalized ear mold. The final prototype has this design. Based on observations from the printed prototype, a new connection piece was created. Let's talk about design specifications. The device is made out of silicone, which is biocompatible and will limit skin irritation. The only cost is the print itself, providing that there is access to a compatible iPhone, computer, and 3D printer. The device can be easily removed and replaced by the parents and is personalized to each ear. But this design was not created overnight. We started creating prototypes with the silicone sealant. We then moved to a silicone called Dragon Skin and tested different types of silicone hardnesses. We determined that the silicone hardness that was preferable was 2A, which is quite soft. Here are some of our past iterations. Iteration 1, Silicone Sealant. Step 1, spray hydrophobic gel on 3D printed ear to make device easily removable. Step 2, dispense silicone onto the ear. Step 3, wait 24 hours for the silicone to dry. The second iteration is Silicone Sealant with Breathability. Step 1, spray hydrophobic gel on 3D printed ear to make device easily removable. Step 2, dispense silicone onto the ear and add fork prongs. Step 3, wait 24 hours for the silicone to dry and remove prongs. The third iteration is Dragon Skin. Step 1, submerge 3D print in silicone and let dry for roughly 2 hours. Step 2, cut off excess silicone from the ear. Step 3, remove 3D printed ear from the mold. Here are the mesh mixer models we made. Iteration 4, Mesh Mixer. Step 1, import ear scan in Mesh Mixer. Step 2, alter the ear to obtain a desired shape. Step 3, place the altered ear into the device template. Our finalized two-piece device. These are the different devices we created in Mesh Mixer. We had to design the best way to attach the two components together. We finally settled on this design. Currently, this design is being printed. We hope to receive this print in a couple of days. This is the cost breakdown for our prototype. The print was outsourced through a company called Proto 3000. The outsourcing price was $125. An adhesive was required to secure the mold, costing roughly $25. The total cost of the device is $150.
Wow, thank you so much for that information. This device seems like a great fit.